Today we'll be doing an example code on interfaces in Java, and we'll be also doing an example on encryption, introduction to encryption and the Caesar Cipher, and how that works, how the algorithm is implemented for that one. So first, I've created a class called main.java, so you can just go to your src folder, click new, Java class, and then type in main.java. And then for the next one, we'll do the same. And we'll create an interface named encryption. .java, and that's an interface, and we'll hit enter. So we have public interface encryption main, and then we'll create one more class. We'll call it encryptor. .java. Hit enter. I'll just write these up from scratch. So we'll start in the interface. So public class, public interface encryption. And then we'll create two methods, two abstract methods. Public void encrypt, and public string decrypt. So this method returns a string, and this method returns a void. And we'll just say, we'll say represents an interface for an object that can be encrypted and decrypted. Save it. And then we'll go to the encryption class. I know what these are mixed up, so I'm going to cut them. I'm going to paste that in the encryption class. Sorry, I can't see, it won't let me make those bigger. So, an interface, we've created a public interface named encryption, and it represents an interface for an object that can be encrypted and decrypted. It has two abstract methods. Remember that from the notes that an interface's abstract isn't usually written, but you can write it. You can write them, but in interfaces, usually it's not. So it's an abstract method. We'll just write that it's an abstract method. This method returns a string, and this method returns a void. So we'll go to the encryptor class, and we'll import java.util.random, so we can use the random class. And then we'll say public class encryptor, implements. So we'll implement the interface that we created. named encryption. So we'll implement encryption. It's hard to spell. So public class encryptor implements encryption. So we'll create a private string named message. And we'll create a private boolean variable named encrypted. We'll create a private int variable named shift. And we'll create a private random generator of type random, so we can use it in the random generator. And we'll create a constructor, public encryptor, and it'll take a parameter that's a string. We'll call it the same as message. And we'll use the this keyword to instantiate message. So when you use the this keyword, it's going to take the global variable. So this refers to the global variable message. And then we'll say equals to the parameter message. We'll set encrypted equal to false. And we'll say generator equals new random. And we'll set shift equal to generator dot next int of 10 plus 5. So 10 random shift equals generator dot next int of 10 returns 0 to 9. So plus 5 equals a generator that returns 5 to 14. Returns an integer between 5 and 14. Then we'll implement the methods from the interface. So we'll say public void encrypt. And we'll say if not encrypted. So they didn't explain this in my textbook when I was learning, or in anywhere in the notes or anything in the slides, or any of the books that I learned from. So basically when you call encrypted without the not operator, so just referencing encrypted, the boolean variable encrypted, it's asking if encrypted is equal to true. So saying if encrypted, it's asking if encrypted is equal to true. It's asking you that. But when you're saying not encrypted, it's asking if it's equal to false, because anything that's not true is false. Originally I thought that it was asking if it's true because encrypted was equal to false. But that's not how it works. It's just calling encrypted is asking if it's true, and calling that with the exclamation, which is a not operator, is asking if encrypted is equal to false. So then we'll say string masked equals just an empty string. Then a for loop in index equals to 0. Index is less than message.length. So we're iterating through the string, and then we're saying index plus plus. So we're indexing to the message that's going to be passed into the object that we're going to create. And whatever message that is it's going to iterate from the first index, which starts at 0, and it's going to go 0, 1, 2, 3, 4, 5, maybe all the way to 20, minus 1, since index started at 0, and the string length is 20. That means it's only going to go from 0 to 19. So we're going to say index plus plus. Then we're going to set mask equal to mask plus. So this plus becomes a string concatenation because there's one string in the operand. Plus a casted char, so it's going to turn the string into a character. It's basically the same thing, but it's going to take them individually instead of the whole string. So when you write a string, there's a whole string there, and the char is just going to cast it into a character. So it's going to cast character to the string message dot char at. It's going to call the char at method of index that we're iterating through, which is going to start at 0, and it's going to add shift. So we'll just say a note here: if either or both of the operands of the plus operator are strings, then string concatenation is preformed. So then we'll say message equals to masked. We'll set message equal to masked. So now our string message is now equal to masked. And then we'll set encrypted equal to true. So now if you check this, checking if not encrypted, it's now true, so it's not false, so it's going to skip this method. It's going to skip this if statement because the condition didn't meet the condition that it was asking. So then we'll implement the other method in the interface, so public string decrypt. And we'll ask if encrypted is equal to true by just calling the encrypted boolean variable. The primitive variable. Whoops. So if encrypted is equal to true, which it now is if we've already passed through this method, because encrypted was set equal to true now. So we'll say if encrypted we'll create a string named unmasked, and we'll set it to an empty string. And then we'll create another for loop. We'll do the same thing, so index equal to 0, index is less than message dot length, and we'll say index plus plus, so it's going to iterate through the whole message. Then we'll say unmasked equals to unmasked, so it's going to create a string concatenation because one of these strings in the operand is a string. So it's going to say unmasked, which is currently an empty string is equal to the empty string plus a casted char of message dot char at index dot index minus shift. So what it's saying is the unmasked string, which is equal to an empty string, is equal to the empty string plus message.char at index, which the first iteration is 0, minus shift. So shift comes from the random generator, which is a number between 5 and 14, which is the shift. It's translating from the Unicode character index. So on the Unicode character index in a Caesar cipher, it's a certain, so it's like capital letters and then symbols, or symbols and then capital letters and then lowercase, something like that. And if you're at S, if our message is like Sally, then on index 0, which is S, it's gonna add shift, which is any number between 5 and 14. So if our random generator gets like 4, S is gonna become 1, 2, 3, 4. S is gonna become F. So that's the encryption. That's how it encrypts. But this is a decryption, so it's gonna minus F. It's gonna minus 7 from F, or we said 4. So 1, 2, 3, 4. So our S or D is gonna become F. So if it was S. So if our encryption, when we ran through the encrypt method, if it turns our S and our random shift was 1, 2, 3, 4, then when it added shift on the decrypt method, now it's gonna minus shift. So it's gonna minus 1, 2, 3, 4. So we're gonna end up with S again, so it's gonna decrypt our encryption using our Caesar cipher, which actually is just the Unicode character index. It's going to just run through each of the symbols because they have a number reference to it, so it's just going to add to those number references. So for example, D is 1, A is 2, S is 3, D is 4, K is 5, J is 6, F is 7. So it's going to minus 1, 2, 3, 4, and we're going to get back to S. So then we'll set message equal to unmasked. And then we'll set encrypted equal to false, because now it's not encrypted anymore, it's decrypted, so encrypted is now false. So encrypted is set to false, it's not encrypted anymore. And then it's a string method, so we have to return a string. So we'll say return message. And we'll create another method of type boolean, so public boolean is encrypted. Then we'll return encrypted. We're returning the boolean primitive variable encrypted. You're going to see that a lot in software development, because usually we just need these methods to just return a single variable. So it's actually, once you get the hang of it, it's pretty easy, and they can be very helpful too. Like when you're using getters and setters later on we'll see some examples of that. So basically this is, it's kind of is an accessor method, because it's accessing one of the variables. So we could also say get is, you could call this get is encrypted, but we don't need to do that. We'll just say is encrypted. So then we'll create another method. Actually, we are overriding this method. We're overriding this method because it's already created. I think it's defined in the object class. That's what we said in the notes. So we're just overriding the toString so that it can be helpful for the way we want to use it. So we're going to return message. Otherwise, I think it just returns like a memory location. So it returns like hash code. So we've defined this method, public string toString. It's overriding the toString method of its parent class, and then we're returning message. So we'll save that, and then we'll go to the main class. So we'll just say public class main. We'll say public static void main. We'll call the command line, and we'll say string array args. And then we'll create an object of type encryptor. So we're going to create a class. We're going to create an object of type class encryptor. So we're going to say encryptor. We're going to call it obj. So encryptor object obj equals to new encryptor. And we'll just say encrypt this string. Then we'll just print out obj, and then we'll call obj the encrypt method on the object obj. Then we'll system.out. Obj again. And then we'll decrypt that same string. So obj.decrypt. And then we'll say system.out.print. ln. We'll print obj again. So we'll run it. Save and run. Line 13 plus 5. Try that again. For index equal to 0. Variable index, can't find symbol, 32 unmasked equals masked. Unmasked equals masked plus char. Dot char at minus shift. I think we have to say index here. Oh, forgot to set that. Index, and yeah, it should work now. Okay, so we typed in encrypt this string in main. So we created an encryptor object, obj equals new encryptor, and then we said encrypt this string. So we passed the string encrypt this string. And then what it did was it took E, and I don't have the actual Unicode character index. I think it's written in, it says it's under the Latin subgroup, so it starts with Latin, and then you're going to find capital E, and then you're going to look at capital P, and then you're going to go how many spaces away from E is P on that index, and it should be the same number for all of them because shift doesn't change. That's how this works. In this way, we didn't change shift every time. If we did, it would be more complicated. So that way, it's just kind of a way to understand it. So it's taking the Unicode character index of E in the Latin subgroup, and it's saying, I think you can find that on Wikipedia, but so from E to P, it's a certain amount, and it's going to be the same amount from lowercase n to y, and the same amount from lowercase c to n, and the same amount from lowercase r to this symbols, because there's symbols on there too. So then after we print out the string we want to encrypt, we encrypt it, and then we take the same encrypted string and we decrypt it. Instead of adding E, a certain number, to P, we're going to take P and we're going to subtract the same number to get E, and that should work for all of them. And that's how the Caesar cipher is encrypted. Thanks.